Hi, my name is Matthew, and in this video we're going to talk about solving rational equations. And the process of solving rational equations, well, it involves working with equations, but that's different than what you might have seen in the previous video where I was working with and simplifying complex fractions. In that video, I got to use what I call my favorite trick. It's not even a trick, it's a tool. And the tool is multiplication by 1. And multiplication by 1 is used in order to create common denominators, among other things, but that's what I was using it for in that video. In this section and in this video, we're going to see fractions. So we are going to be seeing denominators, sometimes just with numbers, sometimes variables, sometimes expressions like x minus 3, but we're not going to create a common denominator across the entire equation. Instead, we are going to figure out what the common denominator would be. But then, instead of actually creating that common denominator, I'm going to multiply the entire equation by the common denominator. Let me show you. This first fraction is a good example because the denominator is not very complicated. The common denominator here is pretty clearly, at least I think it's pretty clear, that the common denominator is x. And so I'm going to do exactly what I told you I'm going to do, which is I'm going to multiply the entire fraction by the lowest common denominator, x. So if you want to write some little notes, you might take note that the LCD, lowest common denominator, is equal to x, and then we're going to multiply by x. Or if you want, you could write that we're going to multiply by x over 1. And I like to write that we're going to multiply by x over 1 to really highlight that the x is going to multiply into all of our numerators, and the 1 is going to multiply into the denominators, or in this case, there's only one denominator. And that multiplying of 1 into the denominator isn't going to change anything, so I won't even write it. So we're only multiplying x into the numerator. In order to really drive this home, I'm actually going to rewrite this equation real quick. I'm going to write it as x over 1 plus 32 over x equals 12 over 1. Okay, that's just the original equation, but that way it's all fractions. All right, now let's multiply the entire thing by the LCD over 1. And as we distribute this x to all of the numerators, we end up with x squared over 1 plus 32, how about 32, times the x, and that equals 12 times the x. Now this 32 over x did still have a denominator of x, and if you'd like, you can keep that original denominator of 1 under the x squared and the 12x. So this denominator is the most important one to bring along with us because really it's the only denominator that we had in the beginning. But if it's helpful to you to see all of these terms as fractions, I will let you decide whether to write them as fractions, or if it's just more clutter and it's more confusing, don't write them. That's okay. Just keep that middle denominator of x. What I'm going to do now is I'm going to reduce. So I've used the LCD. I've multiplied the LCD into my equation in order to not create a common denominator, but to get rid of all of my denominators. In this case, we only had to get rid of one denominator, the x, and that leaves us with this equation, x squared plus 32 equals 12x. This is still an equation that we need to solve because it's got an x squared and an x to the first power and a constant term. It's looking like a quadratic equation, so let's push everything over to the left-hand side by subtracting 12x from both sides. There's a little minus 12x. And I'm going to rewrite this now as x squared minus 12x plus 32 equals 0. And then I'll finish solving the equation by factoring. So if you want to write factor over here, you can. And in this case, the factored version of the left-hand side of this equation is going to look like what we often think it should. Parentheses times parentheses. It's a binomial times a binomial. And if we FOIL it, the f times the f, the first terms, should give us x squared. So that's how I knew to put x's there. And the last terms, when we multiply those together, the L in the FOILing process, we should get a 32, a positive 32. Now, those two numbers also need to add to negative 12. So what are our options? Negative 1 times negative 32. Those are not going to add to negative 12. What about 2 and 16? Not quite. 3 doesn't work. What about, what do you think? Maybe 4 times 8? 4 and 8. Oh, wait, they need to be a negative 4 and a negative 8. Do those add to negative 12? They sure do. Negative 4 and negative 8 it is. So many of you probably know how to factor relatively simple expressions like this already, but anyway, I talked my way through the process. The zero product property says that in order to finish solving this equation, when I have the product of two things equaling 0, either the first thing must be 0 or the second thing must be 0. In order to make the first equal to 0, x must equal positive 4, and the second, x must equal positive 8. Now, are those our two final answers? Potentially. Don't forget to do a check. Anytime you're working with an equation that has a variable in the denominator, you shouldn't submit final answers until you just take a quick glance and make sure that plugging these two potential x values, in this case, back into the original equation isn't going to accidentally cause division by 0. And in this case, it's not going to, but you should put yourself some kind of a note, and I'm going to let you write it out however you want to. But put a note right there that says, check to make sure neither of these x values causes division by 0 in the original equation. If it does, do not use that particular x value as one of your final answers. Just use the other one. Okay, in this case, they both work, so I am going to put x equals 4 and x equals 8 as my final answers. I'll put those in a box. If you're typing them in online, you'll probably just have to type in 4, 8. Maybe you'll be typing them into set braces with your answers separated by a comma, something like that, okay? And then let's try another one. Solving this equation, you should know that x squared minus 9 is a difference of squares that factors to equal x plus 3 times x minus 3. So if you wanted to, you could write down this original problem and then put a little note over here maybe that says x squared minus 9 equals x plus 3 times x minus 3 or something, just to remind you of that fact. If you already know it, you don't have to write that down. But even if you took the time to rewrite the entire equation, so copy down the original equation and then rewrite it with this denominator in its factored form, x plus 3 times x minus 3, so that you can see very clearly that the lowest common denominator is x plus 3 times x minus 3. The other way that you could think of the LCD, and you know what we're going to do with it, I'm going to multiply that LCD into my numerators. The other way that you can think of that strategy is it sort of answers the question, if I were going to multiply some stuff into these numerators, enough stuff has to get multiplied into those numerators so that I'll be able to cancel out or reduce away all of my denominators. Well, in order to cancel out this denominator, I better have an x plus 3 up here. And in order to cancel out this denominator, I better have an x minus 3 up here. And to cancel this one out, I need both of those, so that's nice, an x minus 3 and an x plus 3. But remember, what you do to one side of the equation, you have to do to the other. So we have to multiply the same stuff into all of those numerators. You can't just multiply an x plus 3 into one of them and then x minus 3 into the other one. Okay, you have to be even-handed about it. So I'm going to write the whole thing out. We're multiplying the entire original equation, which maybe you've rewritten down here. I'm multiplying the entire original equation by x plus 3 times x minus 3 over 1. I'm multiplying it to the 4, and I'm multiplying it to the 6, and I'm multiplying it to the 4. The 4, the 6, the 4, those. All right, and what do we get? Let's write it out. 4 times x plus 3. You don't need to actually hear me articulate this as I write it out. I'm just going to pause, and then when I push play again or record again, I'll have all this written out. All right, there we go. Now, you can see that I've multiplied the x plus 3 and the x minus 3 into all three of my numerators. I did leave my original right-hand denominator as x squared minus 9. If you already had it written as x plus 3 times x minus 3, leave it as x plus 3 times x minus 3. Totally fine. Now, we can reduce. So let's cancel some stuff out. The x plus 3s are going to cancel here. The x minus 3s are going to cancel here. And both of them are going to cancel with that rightmost denominator. And once we've done all of that canceling, let's write down what we have left. That's a 4 times an x minus 3 minus a 6 times an x plus 3. And on the right-hand side of the equation, all we have left is a 4. Now I'm going to distribute, and then I'm going to combine like terms. Boring stuff, but we've got to do it. DIST for distribute. 4x minus 12 minus 6x minus 18. Don't forget to distribute that minus sign there. Equals 4. Then let's combine like terms. 4x minus 6x is negative 2x. Negative 12 minus 18 is negative 30. Equals, I've got a 4 on the right-hand side. Now we need to finish solving for x. So let's add 30 to both sides. Negative 2x remains on the left-hand side. 34 is on the right-hand side. Divide both sides by negative 2 in order to isolate x. And we find that x is equal to negative 17. Amazing. After all of that work, we've only got one potential solution. Make sure that whatever your notes look like, make sure you then write some kind of a note that says, check to make sure this x value will not accidentally cause division by 0. And remember, you're doing that check in your original equation. You will discover that an x value of negative 17 does not cause division in your original equation. Therefore, it is reasonable to submit this as a final answer. So we'll type in an x value of negative 17 as our final answer. Nice job. And there's another equation. Now, you've got interactive homework assignments where you can go in and try a problem and click to have it show you a worked out solution. You can go into an ebook perhaps and see some additional worked out solutions to these kinds of problems. I don't want to do problem number 4 because it's so similar to the previous problems that we did. It's very much a combination of the previous problems. Let's have a look. In problem number 1, which is right there, there was only one denominator, which means that the other two terms, the x and the 12, did not have a denominator. My recommendation to you was to put them over 1. In problem number 4, why am I doing that? Let's go like this. Way down there, at the bottom of your screen, there's a 1 on the right-hand side of the equation. If it's helpful, write that as 1 over 1. In problem number 2, we had to get rid of these different denominators, a denominator of x plus 3 and a denominator of x minus 3, and the third denominator, which contained an x plus 3 and an x minus 3. How did we do that? We multiplied all of the numerators by x plus 3 and x minus 3. That allowed us to cancel out all of the denominators. You want to be doing that same kind of a strategy in problem number 4. Multiply all of your numerators by the LCD. Here's us multiplying by the LCD. Here's us multiplying by the LCD. Okay, and distributing it to all of the numerators. Please, this is the part of the process that you really need to commit to memory. All of these problems are going to look a little bit different. Our first problem only had one denominator. Problem number 4 has 2 denominators. Problem number 4 on this page, the one at the bottom of the screen, has 2 denominators. The problem in the middle of the screen has 3 denominators. Right, so you're seeing the variety there. But the strategy was exactly the same. Multiplying the entire equation by the LCD in order to cancel out your denominators. You don't like fractions. I don't like fractions, except one of the differences between most of you and me is that I've figured out a way to deal with fractions. I've mastered the ability to make them go away. And this is a great topic of sort of a topic within mathematics where you have the opportunity to really hone your skill at making fractions disappear. When you're working with an equation, you have to play by certain rules. One of the rules is what I do to one side of the equation, I have to do to the other. So what are we doing to both sides of these equations? We're multiplying both sides of the equation by the LCD, the lowest common denominator. And what does that allow us to do? Get rid of all of the denominators. And voila! No more denominators. No more denominators. Okay, you love that. I love that. Please do that. Commit that process to memory. Your life's going to be a lot easier. Is there anything else in these notes that we should talk about? Problem number 5 is the same as all the rest of them. You just have to factor that denominator on the right-hand side. I bet you $50 when you factor it, you get x plus 6 times x plus 5. Wouldn't that be nice? Okay, then that's your LCD. Multiply it into all of your numerators. Cancel out all of your denominators. And then we move into this separate little subtopic, which is working with formulas, essentially. And these formulas have multiple variables, and some of those variables are in the denominator, and therefore we call these equations rational equations, because there are variables in the denominators. And what these types of problems are asking you to do are to solve for a specific variable, isolating a particular variable. And we're going to use some slightly different maneuvers in order to make that happen. So I'm glad you're here to check this out with me. In this first example, P equals capital A over 1 plus RT, we want to solve the equation for R. Now, your final answer is going to look like this. R equals. Now I ask you, does that R look like it's in the denominator? I don't think so. Look over here. Is your R in the denominator? Yes, it is. Is that a problem? Yes, it is. Are we going to, in this case, immediately get that R out of the denominator? Yes, we are. However, when we move it out of the denominator, a bunch of other stuff's going to come with it. Okay, we're going to get this whole denominator out of here. Let's try it. I'm going to rewrite my original equation over here. P equals capital A over 1 plus RT. Great. So that's my original equation. Now I want you to rewrite this equation below it, except we're going to multiply both sides of the equation by 1 plus RT over 1. Have a look. 1 plus RT over 1 times P equals A over 1 plus RT, but we have to multiply the right-hand side by 1 plus RT over 1 also. Hey, look at that. On the right-hand side, these 1 plus RTs cancel out, which allows me to rewrite my equation as 1 plus RT times P equaling A. Hopefully you're caught up right now so you can appreciate the fact that this equation doesn't have any more denominator. There's no more fractions. You're welcome, right? You've got a newfound freedom here. Mathematical life without fractions, okay? Can't get away with it all the time, but at least in this video, we are wiping out all of our denominators. I feel like I sound like a used car salesperson. We're slashing prices, okay? Here, I'm slashing denominators. All right, it's getting corny. Let's keep going. We need to get the R isolated on the left-hand side of this equation. First, and I don't like doing this, I'm actually going to put more stuff next to the R. In order to break this R out of these parentheses, we got to let the bad guy in, okay? This P is going to have to distribute into our parentheses so that we can get rid of the parentheses, okay? We got to let the aggressor break into the fortress so that we can let the good guy escape. These are the weird little stories and analogies that I use in my head to keep track of the dynamics of how to work with these equations, okay? Even though I work with this stuff all the time, I still tell myself these silly little stories. All right, so if you want to put a little note over here that says DIST for distribute, you may. We get P plus P times R times T equals that A on the right-hand side is not part of the distributive process. Now, continue isolating that R value. I'm going to get rid of this P by subtracting P from both sides so that PRT equals A minus P. Now, I still want to get this R all alone, so I'm going to get rid of this P and this T. But that P and T are attached to the R by multiplication, so I'm going to detach them by dividing both sides by PT. And if you want, you could write it like this. PRT over PT equals A minus P over PT. That's what it looks like to do to the left side what you are also doing to the right-hand side. The advantage is that it allows this P to cancel out and this T to cancel out, so that on the left-hand side of the equation, the only thing you have is that lowercase r that we're interested in. And on the right-hand side, A minus P over PT. Nice. We have solved for R. In other words, we have isolated R. All the rest of these problems are asking you to do something similar. Problem number 6 says to solve for capital P. All right, you've got to get rid of this T from the left-hand side of the equation, which is attached to the P by division. I recommend you multiply both sides by T. And then this P is attached to the V by multiplication. You better divide both sides by capital V. Go through the motions. You should get a final answer that says capital P is equal to lowercase p, lowercase v, times capital T, all divided by lowercase t times capital V. Then, in problem number 7, you need to be solving for a. There's something that I don't like about problem number 7. It's an equation which is fine, except it has fractions in it. Fractions with different denominators. Do I need to make a common denominator? Not when you're working with an equation. If you need to move up to the earlier part of this video, then do it and go back and keep practicing. Get rid of those denominators. Make them go away by multiplying the entire equation by the LCD over 1. Okay, cancel them out. And let's see, you're going to get, let me just work this out really quickly so that you can have a final answer, and then you can try it on your own. I'm going to multiply the entire equation by AB, which is going to give me B plus A equaling ABC. We're trying to solve for A. So I'm going to, oh, this is actually interesting. So after you multiply this entire equation by AB, and then you simplify or cancel stuff out, this is what you're going to end up with. B plus A equals ABC. Now we're trying to solve for A, but I've got 2 instances of A in this equation. So here's what I'm going to do. I'm going to move all of them to one side of the equation. And in this case, I'm going to do that by subtracting A from both sides, so that I have B equals ABC minus A. All right, that's a little, it looks like I'm solving for B, doesn't it? But I'm not, I promise. So I have grouped all terms containing the desired variable on one side of the equation. And I say that very intentionally because that's a particular strategy under certain circumstances like these where you have your variable in 2 different terms. My A is in this term, and I've got another A in this term. Once I have my desired variable, or all of the terms containing my desired variable, isolated on one side of the equation, I'm going to factor, because that A is a common factor in those 2 terms. So let's factor, and we're doing the kind of factoring where we're factoring out a GCF. We're not reverse FOILing, we're reverse distributing. A times BC minus 1. All right, and you can double check that I factored correctly by distributing. A times BC would give me ABC. A times negative 1 would give me negative A. Perfect, so these 2 things are definitely equivalent. Now I'm still trying to solve for A. I still want to isolate A. And this A has a bunch of stuff attached to it by multiplication right up in there. So I'm going to detach all of that stuff, the BC minus 1, by division. So let's divide both sides of this equation by BC minus 1. Dividing the left-hand side by BC minus 1 equals, and when I divide the right-hand side by BC minus 1, it's going to cancel out with this BC minus 1 that's already there, leaving us just with the A. And we have solved for A. That one's a little tricky, okay? So I'm glad that we got to look through that one together. It may happen that you'll run into an equation or a formula where you'll have more than one instance of the targeted variable or the target variable. So again, group all terms containing the desired variable on one side of the equation. Just those terms. Right here's the ABC and the minus A. Get those terms isolated on one side of the equation. Factor your desired value out of those 2 terms in this case. So I got that A out of there. And then I got rid of this stuff by dividing both sides of the equation by those leftovers. The next problem is the same strategy as the first example problem that we did. So go forth, attempt some homework problems, use all of the resources available to see problems like this worked through step by step. Stay organized. Math is like the most organized thing that I do. And I'll admit, I'm like generally a little bit neurotic, I suppose. I just thrive in an organized environment where I can see the progression of how things play out. But look at this. My mother would be so proud. This looked nothing like my high school or junior high locker, okay? That thing used to look like a bomb went off. I mean, nightmare. I should have put a shelving system in it or something, but my affinity for organization didn't come until later in life. Look at these, if my pen will work, look at these equal signs, how nicely they line up. Look at these equal signs. Oh my gosh. Mom would be so proud. All right, go make somebody proud. Go make yourself proud. Do some nice organized work. Get a whole truckload of right answers. Get hundreds on homework assignments. Ace your tests. And I'll see you around. Thanks.